Still some alarm sounds. But again, morning everyone. The title of this session is quite long, but in the end, it's quite simple. It's combining a model like ChatGPT with inputs from a vector database as context and using it for whatever you're trying to achieve. And I will introduce you into our case. Oh, there's another one coming. So maybe I give you a sec to stop that. At least I saw it coming. So I will introduce you into our case. Show you a little bit of how we achieved it, how our setup looks like, and then talk about advantages and challenges that we see with this kind of approach. But before we really start, I'm a bit curious to get to know you a little bit better. And I recently saw this number that 92% of developers in the US are using AI coding tools for their work, and I wasn't really surprised about that, to be honest. Well, because most of us probably use them every day. But I'm more curious about this: how familiar you are with such a screen. How many of you already trained your own models? Let it be for predictive analytics, for image recognition, for everything. Quite a few, cool. And some of you already did stuff with large language models, trained them yourself? Not so really. So yeah, that can be quite a journey. But the good thing is you don't need this knowledge for this session here, because we're just basically going to bridge some APIs and put it together with some data infrastructure to achieve what we are trying to achieve here. Shortly about myself, I'm a product manager for multiple AI solutions at bonprix here in Hamburg. But let's get into the topic. We translate product texts into I'm just going to continue into 13 different languages, and we do that because we have our own fashion products. So we create them ourselves. They are our very own brands. And this means we have to write text for them, the typical titles you see in the online shops. And then we have to translate them into many languages because, as you can see on the map, we are active in quite a few countries. And of course, then these texts, it's quite a task to translate them all. And we wanted to give the translators a nice head start, that they already have a good translation available that is as good as possible to start working with that. And you might ask yourself why we haven't used any typical standard machine translation tools. And it's because of examples like this. It's easier to understand when you're speaking German, but in this case, hairy knit was like very literally translated into haarig gestrickt, and you wouldn't really say that in German. You would definitely just use the English term, and everyone would be a bit confused to just read that. And there's another great example, and these are all real examples from a very well-known tool. This is the mom jeans, the English term translated into mama jeans, and also that it might sound funny in a shop, but of course we wouldn't want to put that, and so that wasn't really a solution for us. But there are even more examples that are not just funny, but that would really lead to a wrong product. And this example, like the bügellose BH in German, was translated to underwired bra, and bügellos basically literally means that it shouldn't have a wire, so it was translated in a really wrong sense. And just to clarify, these tools are usually very great, and the only problem is they're not really domain specific, and they don't understand the context, especially when you put in really, really short terms, like exactly what I did here, because then they don't know what it's really about, and they only understand this very given term. But in the end, it's all about the context of understanding what we are trying to achieve. Well, this doesn't work here anymore. So the models need to know more about the product, and we try to figure out how we can put in this context and let the models understand our brand language, the fashion terms we use. And we started all this in a small hackathon, put together a small prompt that we set that could be a good starting point of how to do such a translation case. And we quickly said that few-shot prompting would be a great starting point, because this basically means exactly as you can see it here, that you have a couple of examples of similar products of the past that were already translated and validated by professional translators. So we would just get them from the database, put them in there, and have a good starting point for the model to understand what we actually want and have the context. And then, of course, we combined that with some instructions like don't make up some stuff, stick to the facts, and similar instructions usually work quite well. And a nice hint, it's great that you can just put in JSONs for each of these small text snippets that are marked here in black, because there are quite a few of them and they're quite long. And you also get a JSON back with the very same keys, so it's very easy to parse, and it saves you at least some time. And then we came up with the idea that we wanted to add a bit more content, and this were basically, beside the just past translations of full products, just some small text snippets that were coming from these longer tags that we said we want to put them in there when they fit to the text that we actually want to translate. And of course, we also wanted to put in some product attributes, because they're categorical. So what's better than that? We only have to translate them once, and we can always put them in, and we already have them anyway. So that was the easy starting point. But then we ask ourselves, how do we find these similar product tags? The easy starting point would have been like just choosing products from the same product category, but we wanted to have a really close match to avoid these samples that are showed here earlier. And so we quickly started with text embeddings. They are basically exactly what you can see here on the right. They are just a vector. They're a mathematical representation of the text that you see on the other side. And they are this representation in a semantical way. So they really represent the meaning and not just a combination of words stuck together in a list. And this is done by using embedding models. Embedding models are small AI models that create these embeddings for you. They are available open source. They're good commercial offerings. OpenAI has some nice APIs to get embeddings like this, but also the open source ones. They're quite small, so you can even run them on your own machine without any big problems. So you can easily play with it without paying any money for that. But what do they really help you with? So these vectors are basically all in the end are present in a big vector space. And once you have this vector space, this means you can find vectors that are really close. And when you find vectors that are really close, this means they have a similar meaning, a similar semantic context to what you're looking for. And you basically try to search them. And you don't have to do this and implement this all yourself. There are great tools for this. There are vector databases. There are some libraries that help you to do this. A good and very lightweight starting point is using a library called FICE. It's you can basically run all the stuff in memory, and it works really fast. And it's even used by some of the vector databases as an engine. So that's a perfect starting point. But when you want to add more features like full text search or additional where clauses, you're going to end up with one of these bigger database solutions. There are quite a few out there, and they all have their pros and cons. We tried some of them, but we didn't really become experts, to be honest, because we quickly went with OpenSearch for the very simple reason that some colleagues were already running an OpenSearch cluster for our GitLab full text search. So we basically just said we want to use it as well. So that was the easy way out for us. But how does our full setup look like, and what all tech did we use? Well, in the end, we are data scientists, so it was quite obvious for us that we do everything in Python, and most of the other choices around it were also, I would say, very common for the field we're in. So we used Fast API for building a small API. We built like a prototyping UI app with Streamlit. It's a small web framework. And then we used some tools for visualization together with the given infrastructure of databases and cloud infrastructure. And in the end, this is kind of how it looks like. To be honest, it's not 100% like that yet. There are still a very few points that we need to improve to make it look exactly like this. But in the end, it's that we have an Oracle database where all our product data is in, and next to it there is now this nice small vector search, the OpenSearch. And this is fed by a small service that we created that is basically just grabbing the original text from our database, getting the embeddings from OpenAI and putting them back into the vector database. And then we have another service that is our main translation service that then uses this search service to find similar context, to feed the whole prompt with the future prompting, and then again, bring it to OpenAI, but this time to one of the GPT models and get back the translations. And as said, the translations are already a perfect JSON in the exact same structure what we have been looking for, so we can nearly directly bring it back to the user applications that actually use it, that improve the translation and so on. One of them is a product information management system where all the product data comes together, and another one is this small test app that we created. This test app looks like this. So basically, we again went the lazy way and just directly put the JSONs in there. But we also put some more product data like attributes and images and so on into the app, so that professional translators actually gain a real understanding what this is all about, whether it makes all sense, these texts. And we also put the old original translations in case they already exist into it. So we have a good starting point to also calculate metrics and so on. So what are our takeaways of this project? The biggest topic for translation topics, but also for many other topics with large language models, it's quality evaluation. With a lot of things, there is not just one right answer. And especially for translations, for longer texts, there can be hundreds of different good texts being the translation of the original text. For shorter ones, that can be different. There might be only one or two choices there. But for longer ones, there is not one right answer. So you can still calculate scores that try to track your accuracy. They're called blue, so they're one of them. That's a good starting point to understand how good your translations are, but it's really just an indicator. And next to it, there is the possibility of model self-evaluation. It's a quite funny concept. You basically ask the same model again what it thinks about its own job. So you just ask what do you think about this translation? Was it a good one or not? And you can even try to ask it to classify it. But again, that's just an indicator, so it's still not the full thing. And well, the full thing is human evaluation, but that costs a lot of time, especially if you want to try many different prompts, if you want to try many different models, many parameter combinations. So that is quite a journey, and that's basically also one of the reasons why we built this app, to try to make it as easy for the translators as possible, and to get an understanding as quick as possible without giving them too many samples. But there are even a few more challenges that apply to this case, but also to some other cases. One risk is model drift. And when you're not in control of the model, you didn't train it yourself, you don't host it yourself, you don't own it, they might retrain it. And they might retrain it at a time when you don't expect it, and then the model starts behaving different. And you basically have to start this whole evaluation process again with asking the translators to help you, or you just rely on the scores as an indicator, and when they drop, you get suspicious. Nevertheless, it's kind of an issue. OpenAI tries to put in model versions so you can use them, but you never know how long they are gonna be supported. So it's kind of a risk, and that's basically also directly the second issue here. The API availability. We practically had never issues with using OpenAI APIs. But last time I checked, they didn't have any SLA. So if you want to bring that into production, you should really think twice how to deal with that. And if you really want to run it live on the fly, or if you want to prefer to have batch runs at times when the API is available. But there's a good side to that. I will come later to it, but there's one negative side, and that's the prompting. And as much people call it prompt engineering, I think there's a good taste of alchemy in there, and so there's not really a really straightforward way of dealing with it. So basically, what you have to do is try stuff, and then we are back to the evaluation topic, that you cannot try limitless stuff. So you got to have a good hunch, basically, and follow some good practices people are talking about whether we're successful with, but that's basically all you can do. But there are really good advantages, and one of them is a quick start, because you can put these kind of things together in a very short time. The APIs are very easy to use. If you use libraries for the similarity calculation, like phis that are in memory, it's very easy to set up as well. So that's perfect. And then it works with very small data sets. You basically only need to have some context available, and it already works for you. So cases that you couldn't even fine-tune a ChatGPT model via API with, this works. But also for other cases where you have larger data sets like we actually have, this is a great advantage, because when there are new fashion words coming in, like there are always new words evolving, and all of a sudden there's a new word coming up, like the mom jeans, and the model picks it up much faster, because you only need one example of it in your database, and the context is already there, and it starts to understand it. So that's also a huge advantage with this approach. And in the end, you can easily just change your model. So if we tomorrow wanted to opt for using instead like Google Palm, that wouldn't be a really big deal, because again, for our case, it's basically just one API call, and to instead send it over there, it's no deal at all. So that's a big advantage, and that basically also makes the API and unavailability issues quite unimportant, because you can basically just have a second model somewhere that you can use. So these are basically all the points. Thank you.